Today we have Scott with us. He's the Vice President of Performance Analytics of Iteris. He has 25 years of policy and urban planning and software management experience in the public and private sectors. He started his career in the United States Senate, where he made the second web page in existence for U.S. Senator William Cohen. He also worked for 12 years at Navtech Nokia /Here. Scott, why don't you take it away?
Well, thank you for inviting me today. I'll try to stick to my 15-minute to 20-minute window so Michael doesn't pull out his bullhorn. And what I'm going to talk about today is an interactive dashboard that we're implementing for the state of California for MAP21 system performance measurements for the P3 rule. I'll go through a little bit about what big data is for folks. I think this is probably a fairly educated audience, but just to cover that briefly, defining what congestion and reliability mean, and then going into what we're doing with in terms of visualizations for the MAP21 measures. So what is big data in generic terms? It's a series of points that then turn into, that have attributes associated with them, that again get aggregated together, processed into linear or spatial references, and then aggregated to produce values that you can then analyze. What we're doing in this work with Caltrans and in our analytics tools in general is by aggregating the big data into measures and metrics through an interactive dashboard. We both support more traditional measures and the measures that are required through the P3 rulemaking process so that users can both report nationally and analyze locally. So to do this, you need to tell a story. And so these are not the MAP21 measures, but more traditional performance measures that states and agencies have been doing for a very long time. Two of those are, there are three of them represented here in this graph, the mean, the buffer index and the planning time index, where the planning time index represents the 95th percentile travel time or the one of the worst case travel times that you might have. The mean is sort of your typical travel, and the buffer is the spread in between the worst and one of the worst and the median. So what that looks like in terms of, so that happens over a series of days, and you want to measure the reliability, and that's essentially what the performance measurements are asking you to do in the system performance tools. In kind of a standard measure, you could look at that in terms of a block of time or what a travel time looks in one time, or you could look at reliability and what that looks like in a probability density function of travel times over time. And then you want to look at some specific portion of that measure of, do you want to look at the worst case, do you want to look at the middle, do you want to look at somewhere in between? And some of the system performance measures look at things like the 80th percentile to do things, do measures that are called the level of travel time reliability, and I'll go into that a little bit in my next slides. Essentially what you're trying to do is over a large space, visualizing congestion and delay, and this is sort of along a line, how that looks, where traffic backs up, there's a slowing down, there's a creation of a queue, you're creating some sort of threshold that you're defining as to what becomes congestion or unreliable measures. And then there's a cause of that happens at the front of this queue, and then you're then aggregating that up over time and space to produce in some cases a singular number that produces a measure that you're then trying to target against. So underneath the surface, this section below the threshold becomes the delay or the unreliable traffic that you're trying to analyze. You can look at that in different ways, and so this is, instead of looking at down the line, looking over top and down the road from the bottom to the top. And then you can see in this case, this is a contour plot for a heat map where you see the bottleneck cause and the slowing, and I'm representing the same graphic that I showed before as a spatially flat going down the road measure, where you're seeing the back of the queue here and the return to free flow here at the side. So what the system performance P3 rule tells you to do, there are several different sections that are in the requirements. There are different performance measures of travel time reliability, truck travel time reliability, annual hours of peak hours of excessive delay, and then there are metrics that you then calculate for each of those performance measures. In those measures, there are different, the Federal Highway has acquired a data set, which you heard earlier, described as the NPMRDS data set, it's a National Performance Research data set, which has different characteristics, and then the rules prescribe how that's supposed to be measured, how it's supposed to be rolled up, and what you can and can't do with that to produce your measures at the end. So one of the metrics is the level of travel time reliability. That's you do some calculations and you wind up with the 80th percentile over the 50th percentile, and you look at different times of day, and then you try to figure out which of those times of day are above 1.5, and then if you have a section that's above 1.5, then that's considered to be unreliable, even if it's only one portion of that time period. And so you then sort of take all that base data that you have over every location, and you aggregate that up to produce the measures themselves. There are a couple of different versions of the NPMRDS data set. There was one that was originally provided by here to Federal Highway from 2012 to the beginning of 2017. And then there's a second data set that Michael's managing for that's being provided by Inrix through the CATT lab with some tools and some data accessibility for that data set itself. So I'm going to show an example of sort of how that looked like. This is an example from the version 1 where there's a location reference, date, time period, information about the car traffic, the truck traffic, and the data values associated with that. The data in the different data sets is slightly different. So the original data set had gaps in it, and the current data set has places where that's referenced as nulls. And so in some performance measures, you'd like to impute data, and other measures, imputation is not desirable. In our dashboard implementation for California, where you have the ability to do both, so the MAP21P3 measures require you not to do imputation, and the more traditional measures that if you want to do that, and Caltrans has a lot of work where they do we do imputation for them, so we have ways to do the imputation on the same types of data sets to fill in the gaps such that they could analyze data over larger space. To then distill that data that you've done a lot of processing on underneath and up into a form that you can visualize, this is where the sort of the fun elements go. And I having watched the presentation from this morning, I hope that we've hit some of the not too many colors, but just enough colors. Maybe I have too many. I'm thinking of my redesign now that I've watched the presentation. I'm going to go read the book on the train on the way back to Philadelphia. So we have more traditional measures, which you see on the left-hand side, and then the MAP21 measures that you see on the right-hand side. And so we've implemented those into a dashboard concept where we're trying to allow analysts to see the data sets at one click. And then when you select these different locations, so I've selected February in this case, it then changes all the cards on the right-hand side, tells you from month to month and year to year comparisons, whether you're improving or not improving. We have these charts above, one which represents the prior year, one which represents the current year. And then you can do some selections down here in terms of whether you're looking at an area or you're looking at a link. And whether you want to look at particular days of the week or particular times of the day, and you can move these sliders around and play and analyze with the data. So we're trying to do both a very macro level analysis so that you can see what does this area look like. In this case, I've selected a county in California. You can go to a statewide level. You can drill down to an MPO. You can look, and the numbers all change for the measures depending on what you've selected for them. We're using color as context, so in this case I've selected congested percentage, which is for the more traditional measures is below 75% of the free flow speed, and so we're then applying that red coloring throughout the visualization to then say I'm on the congested percentage. When you switch to the blue measure, it switches to speed, and so it tells you something about what you're looking at, so that you know that you're on that particular section. We try to provide text cues on the different portions of the data set so that you can tell what you're doing and where you are, and then guide you through the process that you're looking at, as well as boundaries to show you the area that you're covering. From there, you can drill into these maps. There's charts and tables and maps that you can zoom around in and switch your information to see better. You can drill down into the map itself and see some more detail for them. You can click on the different links and see detail about the link and how reliable or unreliable it is. And then you can, in the graphs, we try to keep the same sort of color context. So we're in the red shading up, the red coloring for the congestion percentage also falls into the red shading behind the lines. So we're trying to carry those themes through to provide users with tools to visualize and analyze data in easier ways. For map 21, it's a slightly different process. So we're not underneath the surface. We're not imputing. We decided to, I think, having watched the presentation this morning, I'm happier with the little lines that we have at the top than perhaps the shaded line underneath, where we're using lines to represent trends. So I'm patting myself on the back for that version. We're keeping the color schemes similar so that you can switch from one element that uses more traditional measures that states might be used to using to the measures that they're required to report to Federal Highway. And then we're using these cards here on the right-hand side, like what we did in the other, to do the trending for a month and year, and to show what the outcome measure is going to be that they have to report back up to Federal Highway. From these sort of menus down here, we're keeping the same type of design, doing the different layers where you could select the different metrics that you want to select, and then to select the time period, and that will then allow you to see for a particular map or for a particular location where your unreliable data is, and so that you can then figure out what you might want to do about it.
To the end.
Okay. Thanks.